Hey guys, welcome back. Today we are going to go back to evaluating limits. And this is called L'Hopital's rule. It's spelled differently depending on the textbook. Sometimes it's L'Hospital, it looks like. But L'Hopital's rule. And it's for determining specific types of limits. This is L'Hopital, by the way. And here's this dude. A little bit of facts about him if you care to pause and read it. Okay, so let's say you had this limit, and up till now, your first approach would be, hopefully, plug in the zero. So you try that, you plug in a zero, and you get sine of 0 over 0, and you're not allowed to have a denominator of 0. So you think, okay, there's no answer, but that's wrong. We also can't fix this with factoring, although there are some algebra tricks you could do. So what else can you do? Well, we could graph it, since that's really the only option that you know of right now. So use your graphing calculator, put this in to the y equals screen, and graph it. And remember, what you're looking for when you evaluate a limit is you're looking for the height the graph approaches when x is 0. So I want you to go ahead and graph it and look for the height at 0. Now, will there actually be a height there? No, because that's a 0 in the denominator. So no, it won't actually have a number there, but you should be able to see what it is approaching. So I plugged it into my graphing calculator, and this is the graph I get. And remember, we're looking for the height the graph approaches as x is 0. And so we're looking for what is this height right here. If you see here, you can see there is no actual value there. There's a hole in the graph. But what does it appear to be approaching? And you could hit the trace function and get to the left and the right of it. But it does appear that this is approaching 1. But that right now is kind of just a good guess. So that brings me to today's lesson. The answer to this is going to be 1. But how else could we evaluate that? And that's L'Hopital's rule. So we're supposed to get an answer of 1 for this. So now let me show you how to do it with L'Hopital's rule. First, you have to make sure L'Hopital's rule applies, and I'll get more into that in a minute. But we go to evaluate this by plugging in 0. Well, what is the sine of 0? The sine of 0 is 0. So in this case, you get 0 over 0, which is considered indeterminate, okay? If you get 0 over 0 or infinity over infinity, those are the two indeterminate cases that we really use at this level for L'Hopital's rule. Okay, if you get either of these two things, then L'Hopital says take the derivative of the top separate from the derivative of the bottom and reevaluate the limit. Now on the AP exam, this is often a free response question, and you have to show that you actually get 0 over 0 first. Okay, so we're going to now do L'Hopital's rule. Find the derivative of the top. Derivative of sine would be cosine. Find the derivative of the bottom, which is 1, and reevaluate the limit. Okay, so now plug in 0, and you get cosine of 0 over 1, and the cosine of 0 is 1. And that was the answer we got graphically. Okay, so let me give you the details again. L'Hopital's rule. Okay, this is L'Hopital's rule, written formally. Okay, if you get an indeterminate form of infinity over infinity or 0 over 0, then do the derivative of the top, the derivative of the bottom, and reevaluate the limit. But again, on the AP exam, you do have to show that you get one of these things, and you actually have to show it pretty formally. So I'll show you what that looks like in the next one. Okay, so here we go. Right now, if I plugged in infinity, the numerator would be infinity, and the denominator would also go to infinity. So you can't just write on the AP exam, if this was free response, you can't just write infinity over infinity. They're super picky. You'd have to say, just to warn you, on the AP exam, you'd have to say the limit as x approaches infinity of, and write it all out, which is a total pain and it feels like a waste of time, but you don't get credit if you don't. And then the limit of the bottom as x approaches infinity. Okay, you got to say it formally, This is infinity, and this is infinity. Now, for me, you can just see infinity over infinity and apply the rule. But on the AP exam, you have to write that formally, okay? All right, now let me get rid of all that. Start over. All right, so we get infinity over infinity. So that is a case where we can apply L'Hopital's rule, and it's very easy. Do the derivative of the top, which is 2x minus 7. The derivative of the bottom is e to the x. And now reevaluate the limit. Okay, well, plugging in infinity here, we'd get another infinity over infinity. Bummer. Okay, well, that's okay. We got infinity over infinity. We can do L'Hopital's rule again. Okay, so now I'm going to do the derivative of the top, which is 2. Derivative of the bottom is e to the x. Apply the limit again. And now you get 2 on the top and e to infinity, which is infinity. And 2 over infinity, hopefully you remember, if this number gets bigger and bigger and bigger and that one stays the same, this would go to 0, approaches 0. Okay? Now remember, don't accidentally do L'Hopital's rule when it doesn't apply. It only applies when you get infinity over infinity or 0 over 0. So don't do it when you have a number in one of those spots. Here's another one. This is an actual former AP exam question. Okay, plugging in 0 right now, you'd get 0. Oops, sorry. Plugging in 0 right now, we'd get 0 over 1 minus cosine of 0. So what is the cosine of 0 on your unit circle? The cosine of 0 would be 1. So this is 0 over 1 minus 1, which is 0 over 0. Okay, well, hey, common trick. You think it's not possible because of that 0 on the bottom, but this is just a case of L'Hopital. So derivative of the top is 2x. Derivative of the bottom, derivative of 1 is 0, and derivative of a negative cosine would be sine. Reevaluate the limit. Okay, plug in 0. The numerator is 0. The denominator, sine of 0 would be 0. So this is L'Hopital's rule again. So we're going to do the derivative of the top. The derivative of the bottom, derivative of sine is cosine. And reevaluate that limit. Now we have 2 over cosine of 0, and the cosine of 0 is 1. So this is 2d. Okay, here's another one. This one looks crazy, and we're going to talk more about what this really is. This is actually definition of a derivative in disguise, but I haven't even taught you that because I did things backwards. Anyway, if we go to plug in the limit right now, plug in 0 for the h's, and if this was 0 and this was 0, the numerator will be sine of pi over 3 minus sine over pi over 3, which is 0, and the denominator is 0. So L'Hopital's rule applies. So we do the derivative of the top. Well, it's not as bad as it looks because the sine of pi over 3, that's just a number. So don't be confused by this guy right here. That's just a number, no big deal. Okay, so the derivative of the top, derivative of sine is cosine of, leave the inside the same, times the derivative of the inside. Well, we're doing the derivative with respect to h right now, so the derivative of this would be just 1. The derivative of this, that's a constant, so the derivative of that is 0, and the derivative of h would be 1. Reevaluate the limit. Plugging in that h is 0, we get cosine of pi over 3. Okay, so look at your unit circle. What is the cosine of pi over 3? Pi over 3 is this guy right here, and those values are in this order. So the cosine of pi over 3 would be 1/2. Okay, so that's L'Hopital's rule. Sometimes, especially if it's free response, sometimes you could even have a L'Hopital question graphically. So let's see what that would look like. Okay, we plug in the 2, so you'd get f of 2 over 2 squared is 4 minus 4, which is 0. Okay, well, what is f of 2? F of 2 is the height at 2, so f of 2 is 0. So this is a case of 0 over 0. Okay, so we're going to do L'Hopital's rule. Right? Do the derivative of the top, which would be f prime of x, and the derivative of the bottom, which is 2x, and reevaluate the limit. So now I'm looking at the derivative at 2 over 4. Well, how do I find the derivative at 2? Hopefully you remember. That is the slope at 2. So you'd have to draw a tangent and estimate it. To me, that looks pretty strongly like down 2 over 2. So I'd say that's approximately -1. So I would say this is -1/4, but this is an estimate, so we may not perfectly agree. Okay? So that's how you do this graphically. Same idea, just do the derivative of the top, derivative of the bottom, but again, only if L'Hopital's rule actually applies. Okay, last one. I'm going to do this one, and again, I'm going to show you it formally in case this was a free response question on the AP exam. Okay, right now, you'd have to write formally the limit as x approaches 4 of f of x plus 2 is, okay, we plug in a 4 and we'd get f of 6, and we look up f of 6, and that's 0, okay? Now we'd have to write the bottom. The limit as x approaches 4 of f of x minus 2 is f of 4 minus 2, f of 2, and f of 2 is also 0. So you have to actually show what this limit equals and what this limit equals to show that L'Hopital's rule applies, if this was a free response question. Okay, and that means write the limit symbol. Okay, you have to write that limit symbol, and you got to show it separate for the numerator and the denominator. Okay, now let's actually find the answer. L'Hopital's rule applies. We get 0 over 0. So now I'm going to do the derivative of the top, f prime of x plus 2, times the derivative of the inside, which is 1, over f prime of x minus 2, and reevaluate my limit. Okay? Once you plug in the 4, you don't need the limit symbol anymore. So now we get f prime of 4 plus 2, which is 6, and f prime of 4 minus 2, which is 2. That means we're going to be finding the slope at 6 and the slope at 2. The slope at 6 is, I'm going to estimate it to be a +2. I don't really know exactly what it is. And f prime of 2, that's the slope here, -1. So this is approximately -2. All right, hopefully you guys are doing well. Your assignment is, I used the book that we used to use in the past, so I made a worksheet of it. You're going to just do 1 through 25 on that worksheet though, okay? But save it because we're going to do more of it tomorrow. Good luck. Hope you're doing well. Bye.